Welcome students. In the previous class, actually we discussed about mechanical advantage and efficiency of simple machines. Okay, and you already know about a few simple machines. Okay, so here actually simple machines can be classified into six main types. Okay, this is six main types. One is lever, second one is inclined plane, third one is wedge, and fourth one is screw, fifth one is pulley, and the last one is wheel and axle. Wheel and axle. Now today we actually discuss about lever, okay, at first, and then inclined plane, wedge, and etc. Okay, so before discussing lever, actually you have to know about what is the definition of lever. Okay, so first point is what is lever, okay, or what is the definition of lever. So what is the definition of lever? Actually a lever is a rigid bar that can rotate freely about a point. Okay, so it is a rigid bar. Okay, rigid bar that can rotate, that can rotate freely about a point. Okay, and here the fixed point is called the fixed point, which is called actually fulcrum. Okay, and also the object to be lifted, the object to be lifted is called load, and the force applied on a lever is called effort, and the force applied on the lever is called effort. So these are the main key points. Okay, at first we take definition of lever. This is definition of lever. Second one, what is fulcrum for a lever, and the third one is what is load for a lever, and the last one is what is effort. Okay, and also we have to know about what is load arm and what is effort arm. Okay, so what is load arm? Actually we have to know two definition: load arm and effort arm. Okay, basically what is the definition of load arm? Okay, the distance from load point to fulcrum. Okay, the distance from load point to fulcrum is called load arm. Okay, And what is the definition of effort arm actually? The definition of effort arm actually the distance from effort point to fulcrum. Okay. So similarly, the distance from effort point to fulcrum is called effort arm. Okay. So from this definition, we can say that load arm is distance. This is actually distance which is expressed in meter unit, and also effort arm is the distance. So that is also expressed in meter unit. Okay. Now, what is the principle of lever? Now we move our second part, that is principle of lever. Okay, that is principle of a lever. So in this case, actually, we take what is the principle of a lever. The principle of a lever states that the product of the load and load arm is always equal to the product of the effort and effort arm. That means load into load arm, according to principle of a lever, load into load arm is equal to effort into effort arm. That means we can say load upon effort, load upon effort is equal to effort arm upon load arm. Okay, so in this case, actually this ratio load to effort is called mechanical advantage of a lever or leverage. Okay, so this ratio is called mechanical advantage of a lever, or this is also known as leverage. Okay, so based on the relative position of load, effort and fulcrum, levers can be classified into three different types, or three classes. So at first we take a problem, then we move to different types of lever. Okay, so we take a problem. The problem is, which is based on principle of lever. Basically, the length of a lever is 3 meter. Okay, so the problem, this is problem, the length of a lever is 3 meter. This is a lever and this length is 3 meter. Okay, we take AB as a lever. Okay, calculate the mechanical advantage of the lever if its fulcrum is situated at a distance of 120 centimeter from the load. Okay, so here find out mechanical advantage. What is the mechanical advantage of the lever when actually load is placed? Okay, where load is placed, actually load is placed, or we can say fulcrum is situated at a distance of 120 centimeter from the load. Okay, so this we take, this is the fulcrum point F basically, and this is your load. Okay, so here actually length of the length of lever is equal to 3 meter, which is equal to 300 centimeter, and length of load arm from this figure we can say 120 centimeter. So this is 120 centimeter, and here length of effort arm is actually effort arm is actually 300 centimeter. So this point is effort. Okay, so from this diagram we can say mechanical advantage, that means load by effort, which is equal to length of effort arm length of effort arm divided by load arm. Okay, so if we put the value, then 300 divided by 120 centimeter divided by centimeter, that is equal to 2.5. So from the numerical problem we can easily find out by using principle of a lever mechanical advantage of the lever. Okay, we can easily find out mechanical advantage of a lever by using the principle of a lever. Okay, now we move our next part, which is basically three different types of lever. Okay, so first one is class 1 lever. Okay, so first one is class 1 lever, and in this case actually the block diagram of class 1 lever is like that. Here in generally fulcrum is situated in between load and effort. Okay, so if we take a simple machine, here actually load is applied and effort is applied in this point, and fulcrum is situated in between load and effort. This is your fulcrum point. Okay, so in this case actually effort arm is equal to EF, and load arm which is equal to LF. Okay, so in this case if we have to find out mechanical advantage of class 1 lever, then we have to depend on the distance of effort arm and load arm. Okay, here are the condition. So first condition is when EF is equal to LF, then mechanical advantage is equal to 1, and the second one is when effort arm is greater than load arm. Then what happened? Actually we know load by effort means effort arm by load arm. So that means when effort arm is greater than load arm, okay, then we get in generally mechanical advantage greater than equal to 1. Okay, and the third one is basically when load arm is greater than effort arm, then we can say mechanical advantage less than 1. Okay, so if we move to our second lever or second class lever, then what is the simply class second lever, then actually what is the basic diagram block diagram of class 2 lever? Simply load is placed in between. If this is your load and this is your effort and fulcrum is situated one end, so that means here load is always situated in between fulcrum and effort. That is why we can say Fe, that means effort arm is always greater than load arm. That means in this case always mechanical advantage greater than 1. Okay, so this is the main point for class 2 lever. And if we take class 3 lever, then the block diagram is like that. Here this is your fulcrum point, effort is situated in between load and fulcrum. This is your load. Okay, and here always load arm is greater than effort arm. That means mechanical advantage is less than 1. Okay, so this is the basic concept of three types of lever. Okay, that is actually discussed in previous class, but today actually we repeat it. Okay, in broad way. And next we discuss about our second machine, which is inclined plane. So what is the definition of inclined plane? Actually, an inclined plane is a rigid sloping surface over which heavy loads can be raised or lowered to a certain height or depth. Okay, so if we take a inclined plane like that, this is the block diagram of inclined plane, and if we name it A, B and C, here BC is actually vertical height and AB is inclined surface. AB is inclined surface. So in this case, actually we use this type of inclined plane AB to do some more difficult work, okay, with less force. Okay, that means a wooden plank kept with one of its edge on a raised object and the other edge on the floor is an example of inclined plane. Okay, so if we put a heavy box at point A and we apply a force like that, and we can easily take the body to the top point B, okay, through inclined surface. Okay, so in this case actually what is the mechanical advantage of an inclined plane? The mechanical advantage of an inclined plane is the ratio to the length of the plank, okay, or to the ratio of the length of the plank or inclined surface to vertical height of the load raised. Okay, so here we can say mechanical advantage is equal to AB upon BC. Here AB is inclined surface, okay, length of inclined surface, and BC is vertical height. And here from this figure we always see AB is always greater than BC. That means we can say mechanical advantage is always greater than 1 for inclined plane. Okay, so inclined planes act as an force multiplier. Okay, so if we use a low force, then we get a large amount of force through inclined plane and we can do heavy work, or it can be used to lift heavy loads with less effort. Okay, so next we move to our third point, which is, or we can take third machine, which is wedge. Okay, so at first we have to define what is wedge. A wedge is a double inclined plane such that the two sloping surfaces taper to form a sharp edge. Okay, that means this type of case occur. Okay, so in this case actually we take two type of or two inclined plane like that. Okay, so here this and this edge inclined plane. Okay, so the sharp edge is used to cut, slice or push things apart. Okay, a knife, a axe and a chisel are some example of wedge. Okay, so what are the examples for of wedge is knife, okay, axe, chisel, etc. Okay, so these are the examples of wedge. So main point is, what is the definition of wedge? Actually, the wedge is a double inclined plane such that the two sloping surfaces taper to form a sharp edge. Okay, so in this case, actually we use knife, axe, and chisel, etc. Okay. Now we move to our second point, sorry, fourth point, that is basically a screw. Okay. So at first we have to know about what is screw, okay, or what is the definition of screw. Actually, a screw is a cylindrical rod marked with winding spiral edge called thread. Okay, so in this case screw is like that. If we take, this is your screw, this is your screw, and here we also get a spiral. Okay, so the tip of a screw is narrow, sharp and pointed. The head has a narrow slit which is used to turn the screw using a screwdriver. Okay, and also the principle of a screw also applied to a nut and bolt arrangement. Okay, and the screw jack used to lift a car. A long handle rotates the screw of a jack and the car is raised up. Okay, so this is the principle actually. So, and also we have to know a screw is actually an inclined plane wound around a rod. Okay, and the final one is actually pulley. Okay, so this is the final one for today's class. Okay, pulley. And what is pulley? A pulley is a wheel or a circular disc that can rotate freely about a fixed point. Okay, like that. If we take, this is your actually pulley, like that. Okay, and you have to put a force at point A, and you move the body, B body, upwards or downwards by using pulley. Okay, with less amount of force. That means a pulley is actually made up of a flat circular disc of metal or wood having a groove along its rim. Okay, a pulley is used to lift heavy objects. Okay, a rope or a metal chain passes through the groove. Okay, so in the next class actually we discuss about different types of pulley: single fixed pulley, single movable pulley, and also how they work. So we have to know about also how they work, and also know about wheel and axle arrangement. Okay, so today actually we discuss about the points. At first we discuss about what is lever and what do you mean by fulcrum, load, effort, load arm, effort arm, and what is the principle of a lever and how they works. And we know three different types of lever: class 1, class 2, and class 3 lever. Then we discuss about inclined plane, wedge, screw, and about pulley. Okay, so in the next class we discuss about different types of pulley: single fixed, single movable, and wheel axle system. Okay, thank you. This is the end of today's class.